Okay, let's define the tangent function. So if I want to define the tangent function, I'm going to do this graphically a couple of ways. First of all, let's suppose I have a point P on the unit circle, and the point P is going to be the point xy. And I'm going to let the angle between the ray OP, so O is the origin out to P, and the positive x-axis, I'm going to call that theta. Using SOHCAHTOA, using my right triangle trig, remember, tangent is the opposite over the adjacent. So if this is my angle theta, the opposite is y, the adjacent is x, so the tangent of theta ends up being y over x. That's one way. That's probably the most common way that people think of tangent, is using the right triangle. Now, I could also think of it in terms of slope. What happens is the tangent is actually the slope of the radius from the origin, 0, 0, out to xy. Remember, the formula for slope is change in y over change in x. So if I do change in y, I have y minus 0. And change in x is x minus 0. So I end up getting the slope is y over x, which again gives us the same value as the tangent. So the tangent is actually the slope of the line from the origin out to the point on the unit circle. Lastly, since we know y is the sine of theta and x is the cosine of theta, we could actually take either of these, which we wrote as y over x, and recognize that the tangent of theta, being y over x, would actually be sine theta over cosine theta. And again, that's something that I'm sure many of you recall from your previous experiences with trigonometry.